Hello, today we're going to talk about spectroscopy and the electromagnetic spectrum. So let's review the electromagnetic spectrum with their different types of electromagnetic radiation. So on this picture, it shows it from the longest wavelength to the shortest wavelength, or the lowest energy to the highest energy. So we have radio waves, microwaves, then infrared. Then we get into visible light, and notice it goes from red to purple. Then UV radiation, X-rays, and gamma rays. Now, again, we have the longest wavelength, but the lowest energy going up to the shortest wavelength and the highest energy at the other end. So just kind of have an idea of that. And the way that I remember, infrared is below red, ultraviolet is above violet. So you can keep those kind of things in order, as well as the rainbow of light. Now let's talk about the different ways that molecules can move. We have the normal, just kind of what we call translational movement, where a molecule is moving from one place to another. That's typically governed by just kinetic energy. But you also have things like the bending of a molecule. So especially if you have a molecule like this, there's forces that are pushing on it this way, or the opposite, where it's stretching, so bending and stretching. You could also have it for a linear. It doesn't have to be a bent molecule, where it is, forces this way or this way. Now, this is very minor motion, but because, the electrons are in a cloud formation, you're going to see a little bit of motion pulling towards the center or away from the center. So that's bending and stretching. You also have rotational motion, so where the molecule is rotating in 3D space. You can also have rotation around a bond, but it needs to be a single bond. So if I have something like this, actually let's go ahead and make one of them a double bond. We'll do it like that. So this can rotate because it's a single bond in relation to this other atom. But a double bond cannot rotate because it's held together by that pi bond, which has the overlap of the p orbitals in kind of a parallel formation. So it doesn't allow for that rotation. But if you have a rotation around a single bond, that works. You can have rotation just in 3D space as well. Now, this is going to be important because we're going to talk about bending, stretching, rotating, and moving on the next slide. But I just wanted to make sure we had these kind of in our heads before we move on. Okay, so you don't need to know this in a lot of depth. Essentially, what you need to know is that of these three, microwaves have the lowest energy, infrareds are in between, and UV visible has the highest energy. And because of the difference in energy, it can have different effects on the molecules. Microwaves can basically only rotate the molecules. Infrared has a little bit more energy. It can vibrate the molecules, so the bending and stretching. And then UV visible has enough energy that it can actually cause electronic transitions. And that is the terminology that you'll see most frequently, electronic transitions, but it's basically when we were talking about atomic emission, when the electrons can move between energy levels. They can move from higher to lower levels, depending on the UV visible, the energy of light that was absorbed. So make sure you just know the difference between the three, and that you know the ranking of the amounts of energy